Good evening, everyone. My name is Sridhar Deshpande, and today I am excited to walk you through my internship project titled as Microcontroller Based Washing Machine Simulation using Pixim Lab. So, let's start with the presentation first. So, let's start with the overview of the internship project. This project simulates a washing machine using a virtual environment provided by Pixim Lab. The goal was to recreate a realistic washing machine interface, like selecting a wash cycle, setting water levels, and monitoring door status entirely through software simulation. The experience involved working on both hardware and software aspects of embedded systems, especially integrating inputs, outputs, and control logic. The internship aimed to develop my hands-on experience in embedded systems by implementing a project from scratch. So my goals included learning to interface microcontrollers with peripherals, writing embedded C for real-time control, using simulation tools instead of physical hardware, and finally, strengthening my problem-solving and debugging skills. So the project requirements are a power on screen that reacts to button input, then the selection of washing modes and water levels, then real-time status display on an LCD, motor control through relays, and proper handling of door status using sensors and buzzer. All of this was to be achieved using a PIC microcontroller in a fully simulated environment. So CLCD display to show the machine status, keypad switches for navigation and control, simulated sensors for door temperature, program modes as I already told, like water levels, start or stop operations. These are the project requirements. So the block diagram of this project includes PIC microcontroller, input buttons, sensors for temperature and door, output for LCD, buzzer, relay motors, communication via I2C protocol. So the embedded system, let's start with what exactly the embedded system is. So it's it's a dedicated combination of hardware and software designed to perform a specific task. For example, washing machine, ATM, car ECUs, and the components of embedded systems are microcontroller, memory, sensors, actuators, categories. Categories of embedded system are standalone, real-time, and network. So this is the basic block diagram of any embedded system, which represents the any common embedded system, which includes the main component that is microcontroller, which is the heart of embedded system. Then DAC means digital to analog converter, ADC means analog to digital converter, human interfaces, diagnostic port, memory, sensors, actuators, etc. So these are the different embedded systems which are shown here by visual representation like microwave oven, washing machine, CCTV camera, car, etc. So basically what exactly the microcontroller is? Microcontrollers are essential mini computers on a chip optimized for control applications. So in this project we use PEAK 18F 477A microcontroller, so which includes the built-in timers, communication protocols, I/O ports, All these are critical for handling the control logic. This is the basic and simple block diagram of any microcontroller. So what are communication protocols? So the communication I2C protocol is used for peripherals like RTC, EEPROM, it is the serial and synchronous two-wire interface. I2C protocol is serial and synchronous communication protocol. It supports the multi-master and slave architecture, and it is useful for scalable and modular designs. So this is the simple diagram which represents the I2C communication protocol, which includes the microcontroller, LCD driver, EEPROM, RTC, microcontroller B, here microcontroller A, temperature sensor, and ADC. So, which are the development tools that are required to build this project? So, Pixim Lab, as I already told, and it was also mentioned in title that Pixim Lab is the real-time microcontroller simulation. Then MP Lab XID, it is the code development ID, which is used for code development and debugging. And the assembly or C for programming, these are the programming languages which are used to program the microcontroller. So these are the implementation details, means power on screen, which is used to print the status of washing machine. Then washing program selection, we need to scroll using switch 4. To power on the screen, we need to use switch 5. We can select the water level, then different water level, then we can select different functions. Then if the door is open, then it will shows us the alert that door is open. And after completion of the operation, it will show the message on screen that remove your clothes. So the conclusion is project enhance understanding of embedded system means not only learn about the embedded system but also build the project. Then provided hands-on with microcontroller simulation. Real-time control logic, interfacing of microcontroller and peripheral devices. Then UI means user interface. Then solid foundation for future projects in automation. As my embedded system uh, is is the main part of any automation, or it's like heart of automation and automation machinery. So the project architecture includes central controller, different input devices like switches, temperature sensor, door sensor, output devices like LCD, relays, then modules for program selection, water level setting, door check, and function execution. So this is the project architecture block diagram which we already discussed. Like microcontroller is the central controller. It is the heart of the system. All the components of system are based on microcontroller. Power on the to power on the machine, we need to use switch 5. Then to pause or stop the operation, we need to use switch 6. For navigation, switch 4. For checking the door status, we need to use switch 1. Then to display the washing status, LCD display is used. Then buzzer and then motor. So simulation screen includes the LCD display which shows the different status of operation, like power on screen which prompt to activate the machine. Then program menu, we need to scroll there and select the wash programs. Then water level screen, we need to choose the water level from the different options available. Then start screen, we show the status of machine or operation. Then function execution displays the ongoing action. Then door status and uh, completion status, which shows the alert if door is open, and if operation is completed, then it shows the status like remove your clause operation is completed. So these are the different simulation screens as I already told. Like press key 5 to power on washing machine. This is the first screen of washing machine. After that we need to press the key number 5 to power on the washing machine. Then after that it will show the status like powering on washing machine. Then the next part is we need to select the washing program, which program we want. Then after that we need to select the water level, like which water level we want. Auto, low, medium, high. These are the different water levels available. Then after selecting the water level, we need to select the start or stop option, like whether we want to start the operation, whether we want to start the machine, or whether we want to stop the operation or exit the operation, or whether we want to stop the washing machine. Then after that, once we start the washing machine, it will shows us the remaining time for to complete the operation. Then during operation, if we want to stop the operation or stop the washing machine, we need to press the key number 6 to pause the operation. Then if we press key number 1, then it will show the status like door open, please close. Means the door is open. If the door is open, then it can't uh, start the operation, or operation may get stopped suddenly. Then, if the operation gets completed, then it will show the status like program completed, remove close. So, real-time considerations are system must be respond to inputs like door open during the cycle. Means system must be able to respond the door open status. Then timing critical operations like wash, rinse, spin, durations. Then soft real-time delay, but user experience must remain intact. Then SW means switch interrupts used to detect the button press immediately. Means the system behaves as soft real-time system, even though it's simulated, but these aspects are closely reflect the embedded development in real products. Then next slide is design challenges. So different design challenges are mapping software logic with hardware simulation, handling multiple user inputs in real time. Like multiple user inputs includes the different washing programs or different water levels. Then ensuring correct transition between the screens. Then testing edge cases like door open mid operation. Then repeated start or stop presses, etc. So system must be able to respond this kind of operations like repeated start or stop presses. Then other challenges includes like button debouncing or recognizing long versus short presses. Then ensuring correct screen transitions. Then handling unexpected behaviors, as I already told, like sudden door open or door close, etc. Then learning outcomes are like embedded C and register level programming of microcontroller, simulation and debugging using PixSimLab, then understanding of I2C based device interfacing, then basics of GUI creation. GUI stands for graphical user interface, crea- that is graphical user interface creation in embedded environments. then effective project documentation and workflow. Then future enhancements are like add temperature control water mixing simulation. Means we can add temperature control water mixing in this kind of simulation or this kind of washing machine. Then we can include EEPROM for storing the user preferences. So if user want to store his preference, like if he want only particular washing program or only particular water level, then he or she can able to store it by using EEPROM. Then add GUI overlay to mimic real washing machine panel. Then implement motor PWM control for advanced cycles. PWM stands for pulse width modulation. Then include GSM or Bluetooth module for remote monitoring. So if user is not available at nearby of the machine, then he or she can able to control the machine using Bluetooth module or GSM module from the uh, any place. So I would like to thank Emerge and my mentors for providing structured training, constant support, and access to helpful resources like Pixim Lab. Thank you for your time, and I am happy to take any questions. Thank you. So let's start with the demonstration of the project using Pixim Lab and MPLab X IDE. So this is the MPLab X IDE version 6.25. Here we can program our here we can write our program and build and debug it using MPLABX IDE. So for that we need to include the header files like clcd.h, digitalkeypad.h, main.h, then source files in uh, in .c format. Like these are the C program files, and these are the text files. So I have already build this program. Let's start with the after writing the program, we need to build it uh, using the this option build project. So after building the project, we need to move to Pixim Lab. So in Pixim Lab, we need to choose the board as Peak Genesis, then microcontroller as Peak 16F877A. I have already loaded the hex file in this microcontroller. That's why it is showing the starting screen as press key 5 to power on washing machine. So let's start with the demonstration. Here I have pressed the case key 5. So it is showing me this starting screen, which we already saw in the presentation, powering on washing machine. So right now it is showing me the different programs which are available. So to change the program, we need to press this key. So after pressing this key, we can change the program like it right now it is showing heavy, delicates, whites. Then again after pressing the switch 4, we can change the program like delicates, whites, 10 wash. So to select any particular program, we need to long press this key or we need to long press this switch. Here we have selected the program by long pressing the switch number 4. So right now it is showing the different water levels. Among them we can choose any one that we want. So right now it is showing auto, low and medium. If we press the switch 4, then you can see it is changing like low, medium, high. So to select any water level, we need to again long press this switch 4. Here you can see we have selected the low, medium and high water level. So to start the operation or to start the washing machine, we need to press switch 5. So let's start with the operation. Here you can see the operation is started and motor starts moving. So to pause this operation, we need to press key number 6. Here you can see the timer stops and motor also stops. So to start this operation again, we need to press the key number 5 again. So here I am pressing this switch 1, then it will show door open, please close status. So if door is open, then operation or washing machine stops suddenly. And if we release it, then it will start automatically again. So here we can see the timer remaining, the time remaining to complete the operation and which function is going on. After the operation is completed, you can see the status like remove clause program completed, and then it will again reset the screen or reset the program to start. Like here we need to again select the washing program. Again, we will select one more program, then water level, then we will start the operation. Here we can able to see the function which is going on, that is wash, and time remaining to complete the operation. If we want to stop the operation, then we can press the switch. And if we want to start again, then we need to press this switch. Now 10 seconds are remaining to complete the operation. And after completing the operation, you can see the status like remove clause program complete here. So this is the demonstration of the washing machine project using Pixel Lab. Thank you all for your time.